All right, everybody, welcome. Welcome back to Eureka Math. This is Module 2. We're going to go over Lesson 3 today. All right, this is Maestro Maravilla. And, all right, let's get started with the lesson. All right, so, I'm back here. All right. So, once again, this is Lesson 3, Interpreting and Computing Division of a Fraction by a Fraction. Okay, so the opening exercise. The opening exercise says, draw a model to represent 12 divided by 3. Well, I can look at my first fraction, right? And I'm going to make 12 little boxes. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 1 to the left, 1 to the right, that's 12. All right, close those boxes. I have 12 boxes. All right, let's close them. So then out of those 12 boxes, I need to break them into pairs of 3. And then how many pairs can I make? So I do 1, 2, and 3. That's 1 pair. I can do 1, 2, and 3. That's another pair. 1, 2, and 3. That's 1 more pair. And finally, I can do 1 last pair of 3. Okay. So out of the 12 boxes, okay, I made pairs of 3. And then I just add how many pairs I was able to make. 1, 2, 3, 4. So my answer is 4. Okay. Create a question or word problem that matches your model. There's many different scenarios. There's many different problems you can create. One example would be maybe if I have 12 pounds of sugar and I want to place them in bags of 3 pounds. Then the question could be something like, how many bags can I fill? And the answer would be, once again, 4 bags. 12 divided by 3 equals 4 bags. All right. So there's that. Okay, so let's go to example number 1. For example number 1, one of the things that I want you guys to notice is that for this type of fractions, these are fractions that have a common denominator. So notice that both of these fractions, the 8/9 and the 2/9, they both have a 9 as a denominator, so they have common denominators. When you have this type of fractions, these fractions are going to be fairly simple because once you get a fraction to have a common denominator, then you're going to look at your numerators, and your answer is just your numerators. So if a fraction already has a common denominator, in this case is the 9s, then you're going to look at the top and your answer is going to be the first numerator divided by your second numerator. So your first numerator in this case is 8 divided by your second numerator, in this case is 2. You can simplify this and your answer would be 4. Right? But remember, this only works if the fractions have a common denominator. Okay? So this particular example is asking us to write the expression in unit form and then draw a model to solve. So let's we can probably do the keep, change, and flip model that we've been using in the previous lessons. So we can do 8/9 divided by 2/9. So that's my division expression. Now I have to turn it into I have to write its equivalent multiplication expression, right? So remember, so I'm going to keep the 8/9. change from division to a multiplication, but then I have to flip the second fraction. But remember that we also called the action of flipping the second fraction the reciprocal. So then the 9's on the top, and then the 2 at the bottom. So again, my denominator and my numerator, they'll flip, they'll reciprocate, they'll change. Now, once I have them like this, then I look across, right? When I look across, look at this 9's, and look at the 8 and the 2. Can they be simplified? Yes. The 9, I can divide by 9, I'll get a 1. 9, I can divide by 9, I'll get a 9. 2 can divide by 2, get a 1. 8 can divide by 2 and get a 4. So now multiply 4 times 1, that'll give me 4. And now multiply 1 times 1, that'll give me a 1. And my answer there is also 4. If I want to do a tape diagram, in this case, I probably want to look at the first fraction. If they have a common denominator, I can always look at the first fraction, right? So in this case, I have 8th, 9ths. So I'm going to do a model that has 9 boxes, and then I'm going to shade in 8 out of the 9. Okay, so let's do that. So we'll do this. Okay, try to make this kind of straight. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Close this. Right, make it as straight as we can. Now, I have a model there that shows 9 boxes, but remember, we only need 8 out of the 9. So we'll go ahead and shade 8 out of the 9. So we shade 1, 2, 3, 4, 5, 6, 7, 8. Now this 8 out of 9, we're going to look at the second fraction and see how many groups of 9 we can have. Groups of 2 9ths we can have. And that's going to be our answer. Okay, so let's go ahead and start doing that. So I can break this once, right? So there's 1, 2. That's 2 out of 9. That's one group. Okay, so group them again one second time. 1, 2. That's 2 9ths. That's a second group. Let's go one more time. 1, 2. That's 2 out of the 9. That's a third group. And finally, the last one, 2 out of 9. That's a fourth group. So all in all, when you count how many groups you were able to do, we were able to do 1 plus 1 plus 1 plus 1. That gives us 4. So 1 plus 1 plus 1 plus this last one right here gives us 4. So my answer there is 4. Okay. So again, your answer is always going to be, you're going to take the first fraction, 8 9ths, and that's going to be your model. Okay. So you're going to make a model where you have 9 boxes, but you only need 8. So you shade 8 out of the 9 because that's your first fraction, 8 9ths. And then you're going to look at the second fraction, which in this case is 2 9ths. So you're going to break them in groups of 9. And then how many groups you can make, that will be your answer. In this case, we were able to make 4 groups of 2 9ths in the 8 9ths. And therefore, our answer is 4. All right. Let's look at example number 2. Once again, when you have the fractions that have a common denominator, once again, in this case, you have the 12s. The 12s is your denominator. Then at this point, we're going to be looking at the numerator because that's pretty much your answer. If you can get the fractions to have a common denominator, then your answer are your numerators. It's the first fraction, it's a numerator divided by the numerator of the second fraction. So in this case, your answer here is 9 divided by 3. The numerator of the first divided by the numerator of the second. That's your answer. You can simplify this. 9 divided by 3 is 3, and that's it. That's simple. That's your answer. Okay. Now we can do this using our algebraic model. So we'll do 9 divided by 9 twelfths divided by 3 twelfths. So if we want to do, now this is our division expression. Now we have to have a multiplication expression. So to do that, we're going to do keep, change, flip one more time, right? So remember this from the previous lesson. We keep the first fraction, we change the symbol, and then we flip the second fraction. Remember, flip is also the reciprocal. Okay? So then we look at this. So then we say keep the first one. So we keep the 9/12. Change from division to multiplication. And then finally flip or do the reciprocal so that the 12's at the top and the 3's at the bottom. So the numerator and the denominator, we change and we flip them. Okay, this is called the reciprocal. Now we look across. We want to look across. So and there's a 12 and the 12, and then the 9 and the 3. And then you ask yourself, can I simplify those numbers? The answer is yes. The 12 can be divided by 12. That's 1. 12 divided by 12, that's 1. 3 can be divided by 3, that's 1. 9 can be divided by 3, that's 3. So then you multiply 3 times 1, that will give you 3. 1 times 1, that will give you 1. You simplify, and then your answer is 3. If we want to do a model, once again, we're going to look at the first fraction. Because we're going to base our model of the first fraction. Remember, when they have a common denominator, we're going to base our models out of the first fraction. So this means that I'm going to have 12 boxes, but I only need to shade 9 out of the 12. So let's do that. Okay, so I'm going to try to make it straight as possible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to close this. Okay, make it as straight as possible. There we are. But now remember, I out of those 12, I actually only need to shade in at 9. So we'll shade 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so that's all I need because I need 9 out of the 12. That's my first fraction. My second fraction says it's 3/12. So I have to divide that into pieces of 3/12. So once again, I'm going to look at that and I'm going to divide. See how many groups of 3/12 I can make, and that's my answer. The number of groups I can make of 3/12 will be my answer. So if I graph 1, 2, 3, that's 3/12, and that's one group, right? So 1, 2, 3, that's also 3 out of 12. That's a second group, right? So I go to the last one here, 1, 2, 3. That's another 3/12. There's no more because I only had 9. And so within those 9, I was able to make 3 groups. Okay, so once again, 1 group, 2 groups, 3 groups. And so my answer, therefore, is 3. Okay, and once again, that's the answer that I got right there. That's also the answer that I got right there. So there's multiple ways of doing this type of problems. Okay, there's the division of fractions. There's multiple ways to approach them. And I kind of show you a couple ways to do it here. Okay, let's go to example number 3. Example number 3. So once again, because this type of fractions have a common denominator, right? They have a common denominator, then really your answer are your numerators, right? Your answer is going to be your numerators. So it's going to be the first numerator divided by the second numerator. That's your answer. That's it. Now you can simplify this. If you simplify, you ask yourself, how many times can you fit that 7 or that 3 into the 7? The answer is 2. But then you have a remainder of 1/3, right? Because the 3 can fit into the 7 twice. 3, 6, that's twice. But you have a remainder of 1, right? And so that's 1/3. And this is your answer here. Okay. Now we can do this using the algebraic model or method. So we'll do this by keep, change, flip. We'll do the reciprocal. So first we have our division expression. Our division expression says you have 7th ninths divided by 3/9. This is equal to, now I have to create its equivalent multiplication expression. To do this, then I use the keep, change, flip method. So keep the 7/9, change from division to multiplication, flip the second fraction. So now then my 9 is my numerator and my 3 is my denominator. Again, this is called the reciprocal. Okay, now that I have them like this, then I look at them across. I have a 9 and a 9, then a 7 and a 3. And then I think, can I simplify those? The answer is I can simplify a pair of 9s. So I can cross out this 9. 9 goes into 9 one time. 9 goes into 9 one time. But the 3 and the 7, there's not really one common multiple for those. So I can't really simplify them any further. So I'll just have to multiply. Okay, so I have to multiply 7 times 1 is 7, and 1 times 3 is 3. So if I simplify, then how many times does this 3 go into the 7? The answer is 2, but I'll have a remainder of 1/3, and that's my answer there. Notice that I ended up getting the same answer. Okay. Again, these are two ways of doing this, solving this type of problems. You pick whichever is easier for you. But if you rather do the model, though, we can do that, no problem. So to get us started with the model, what I'm gonna do here is remember when they have a common denominator, I'm gonna make the model based on the first fraction. So the first fraction says 7/9. So what that means is that I need 9 little boxes, and I'm gonna shade in 7 out of them. So let's go ahead and do 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Close this. Okay, so there is my 9, but remember, I only need to shade in 7 out of the 9s. Okay, so I'm gonna go ahead and shade in. I'm gonna shade in 1, shade 2, shade 3, shade 4, shade 5, 6, and 7 out of the 9. Okay, I only need 7 out of the 9. So now my second fraction says, well, you need to break them into groups of 3/9. Okay, so I need to break them into groups of 3/9. Okay, so I can do that. So what I'll do is I'll grab 3. So I'll grab 1, 2, 3. That's 3/9, right? But one thing that I also want you guys to keep in mind, that yes, that's 3/9, but I'm also shading 3 out of the 3, right? The 3 out of 3 are shaded. Okay, so let's grab another group. Another group is 1, 2, 3. That's another 3/9. But I also want you guys to notice that, right? So from here to here, I shaded 3. And then from here to here, I shaded another 3. So we can say that 3 out of the 3 were shaded, right? So then I'm going to grab my third group, right? So I'm going to grab 1, 2, 3. Keep in mind, though, that over here, I was only able to shade 1 out of the 3, right? 1 out of the 3. Or I was only able to shade 1 piece out of the 9, right? So then I asked myself, okay, how many groups do I really have? Well, I was able to shade 1, 2, 3 right here, 3 out of 3. So I grouped them one time. Look at the next 3 boxes. Then I was able to shade 1, 2, 3. So I shaded 3 out of the 3. But on the last group, only 1 out of the 3 are shaded. So then you would have to think about the answer as in like I was able to shade them to create 2 groups, 2 full groups. But on the last one, only 1 out of the 3 were shaded. And that's my answer. That's the way to think about this. Okay, so I created 1 group. I created a second group. But on the third group, only 1 out of the 3 are shaded. Okay, and so my answer is 1, 2 plus that 1/3. And that will give me the same answer as this. Okay. Alrighty, so then let's continue. Go to exercises 1 through 6. It says write an expression to represent each problem. Then draw a model to solve. So how many fourths are there in 3/4? So we'll start by thinking about this, right? So how many fourths are there in 3/4? So this is telling you that you're going to grab this 3/4, and then you're going to have to break it into 1/4 to figure out how many fourths are there in 3/4. Now, once again, we think about it this way, right? Notice that my denominators are the same. My denominator is a 4. Remember that when my denominator is the same, then my answer are my numerators. So then I can just think about it like this. I'll say, well, my first numerator is a 3. My second numerator is a 1. And so I simplify this, and it will give me 3, and that's my answer. It's really this simple. Okay. You can do it using our division expression followed by its equivalent multiplication expression, which is keep, change, flip, or the reciprocal, and then doing it that way too. So if we do it that way, right, we have 3/4 divided by 1/4. So now that's my division expression. I have to make an equivalent multiplication expression. So to do that, we'll do keep, change, flip. So we'll keep my 3/4, right? Change from division to multiplication, and then flip the second fraction. Second fraction is 1/4. So now the 4 is my numerator and the 1 is my denominator. This is also called the reciprocal. Keep that in mind. Okay. Once I have them like this, then I'm going to look at them across. Look at those numbers like this. So look at the 4s and look at the 3 and the 1. And then you ask yourself, can you simplify them? Well, you can simplify the pair of 4s, but the 3 and the 1, you really can't, right? So the 4, you can cross it out and call it a 1. 4, close it out, call it a 1. Why? Because the 4 can be divided by 4, and that will be 1 time. 4 can be divided by 4 also 1 time. So now I multiply 3 times 1, that will give you 3. 1 times 1, that will give you 1, and then my answer is 3. I got the same answer, okay? So then if I want to do the model, remember to do the model, I'm going to be looking at my first fraction and then doing my model based on that. So I need 4 boxes, and I'm going to shade 3 out of the 4. Okay, so I'm going to let's go ahead and make 4 boxes and shade 3 out of the 4. Okay, so break it in half and then break it in half again. Then I'm going to shade in 1, shade in 2, shade in 4. That's my model, right? 3 out of the 4. Then I'm going to look at my second fraction, right? My second fraction is 1/4. So that 1/4, I'm going to break this into groups of 1/4. Okay, so 1 out of the 4. So 1 out of the 4, well, this is 1 out of the 4. That's one group. Remember, my answer is how many groups I'm able to make. Okay, so then once again, I'm going to do 1/4. That's a second group. And then finally, one more 1/4. And how many groups did I make? Well, I made 1 group, 2 groups, 3 groups. So my answer is 3. Okay, and then I got the same answer in 3 different methods. Okay, same answer. Okay, let's go to number 2. 4/5 divided by 2/5. Once again, you guys notice that my denominator there is the same. When my denominator is the same, then all I really have to do is look at my numbers, my numerators, and that's going to give me the answer. So my answer is my first numerator divided by my second numerator. So my first numerator is 4. My second numerator is 2. I simplify it and my answer is 2. It's really this simple. Again, remember, this only works when your denominators are the same. That's the only reason why it works, because my denominators are the same. Then you can do this, okay? All right, but if I want to just do the regular, the regular way, using the reciprocal method, remember, I have 4/5 divided by 2/5. So that's my division expression, right? Now I got to turn it into a multiplication expression. How do I do that? Okay, well, what I can do is, remember, keep, change, flip. So keep my first fraction, 4/5, change from division to multiplication, and then flip my second fraction, which is 2/5. So in this case, 5 is going to be my numerator and 2 is going to be my denominator. This is also called the reciprocal. Okay. Now, then I look across. Okay. These are the pair of 5s. These are the pair of 2s. And then I ask myself, can I simplify those? The answer is yes. 5 can be divided into 5 1 time. 5 divided by 5, 1 time. 2 divided by 2, 1 time. 4 divided by 2, 2 times. So then you multiply across. 2 times 1, that will be 2. 1 times 1, that's 1, and the answer is 2. Okay. Now, if you want to do the model for this, again, we're going to do it based on the first fraction. So I'm going to make 5 little boxes. 1, 2, 3, 4, and 5. Now, out of those 5 little boxes, I'm going to shade in 4 because I need 4. 1, 2, 3, 4. That's 4 out of 5, right? 4 out of 5. So then I need to break them then after into groups of 2 5s. And then how many groups I'm able to make, that's my answer. So once again, there's 1, 2, that's 2/5. That's one group. 1, 2, that's 2/5. That's 2 groups. So how many groups do I have? 2. So then my answer is 2. Once again, I got my answer using 3 different methods. All right. There we are. So then let's look at number 3. For question number 3, once again, my answer, notice that my numerator for all this, my numerator is the same. Okay, for all of this, my numerator is the same, right? Number 3, 4, and 5. So then if the simplest way to do it and the fastest way to do this is when they have a common denominator, just look, your answer is in your numerator. So it's your first numerator divided by your second numerator. That's your answer. It's your first numerator divided by your second numerator, right? But remember, you got to simplify it. 9 divided by 3 is 3, and that's your answer. Once again, over here, how many times can you fit the 2 into the 7? The answer is 3, but you'll have a remainder of 1/2, and that's your answer. So I did this very, very quickly. And on the number 5, same thing, right? See here, my answer is because my denominators are the same. So my answer on my numerator is the first one divided by the second one. So I asked myself, how many times can I fit that 2 into the 13? The answer is 6 times, and I'll have a remainder of 1/2. Okay, so they all work the same way. This one here, I have a same common denominator. So then my answer is my first numerator divided by my second numerator. Then I ask myself, how many times can I fit the 3 into the 11? The answer is 3 times, and I'll have a remainder of 2/3. And just like that, I found the answer to all those. Okay. Now, if I go back to number 3, and I do it just the regular way. So then what I will do, once again, is I will do 9/4 divided by 3/4. This is equal to, now I'm going to do my multiplication expression. Keep the first one, change from division to multiplication, and flip the second one. Now I'm going to simplify those. Okay, simplify them. So then 3 divided by 3 is 1. 9 divided by 3 is 3. 4 divided by 4 is 1. 4 divided by 4 is 1. Multiply, 3 times 1 is 3. 1 times 1 is 1. And then my answer is 3. Okay, if I want to do my model, then I do it after my first fraction there. So notice though that in this case, the first, my numerator is larger than my denominator. So then that means that I need more than one whole, right? So then I need to make enough, right? So until I get to 9. So then here's what I'm going to do. It says that I need pieces of 4. 1, 2, 3, 4. But that's not enough to cover all the 9. So I'm going to make one more whole. 1, 2, 3, 4. That's also not enough. So I'm going to make a third additional one. Okay, so 1, 2, 3, 4. There. Looks like now we have enough. But now out of all those boxes, right? Remember, I have to do more than one box because notice that my numerator there, it's bigger than my denominator, and therefore the answer is going to be more than one whole because the 4 I can fit it into the 9 2 times and don't have a remainder of 1/4. So I'm going to go ahead and need to shade in 4 of those. Okay, so I'm sorry, 9 of those. So shade in 1, 2, 3, 4, 5, 6, 7, 8, and 9. There you go. So I shaded in 9. Now I'm going to break them into groups of 3/4. So then from here, then I can break them into groups of 3. So there's 1, 2, 3. This is 3/4, right? 3 out of 4. So 1, 2, 3. This is 3 out of 4. 1, 2, 3. This is 3 out of 4. And it was perfectly 3 groups, right? 1 group, 2 groups, 3 groups. So my answer is 3. Okay. There it is. And you can see that I have the same answer all across. Okay, so let's continue with this one. So I'll go number 4. Number 4. Once again, if I want to do a model, then I'll look at 7/8. I'll look at 7/8. So I'll have 8 boxes. So 1, 2, 3, 4, 5, 6, 7, 8. Close it. And then I'm going to shade in 7. So 1, 2, 3, 4, 5, 6, 7 out of the 8. 7 out of the 8. Now I'm going to look at my second fraction. And my second fraction is 2/8. So I'm going to break them in groups of 2/8. So this is 2 out of 8. That's one group. But I also want you guys to notice, though, that I shaded 2 out of 2. Okay. Then I'm going to break it right here. This is also another 2/8. Once again, I want you guys to notice I shaded 2 out of 2. Okay. Then one more time. This is 2 out of 8. Once again, I shaded 2 out of 2. And then finally here I have one more group, but this is not quite a 2 of 8, right? And I was only able to shade one of the two, right? Only one of the two. So then my answer is one group, two groups, three groups plus 1/2. So this is equals to 3 groups plus 1/2. Okay. Okay, so the third one is to the model for number 5. Number 5 model. Okay, so I'm gonna do it based on this one. So I'm gonna need to do my 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Close it. But once again, that's not quite enough, so I need another set of 10s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Close it. Okay, now I need to shade in 13. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So then now I need groups. I need groups of 2 10s. So then 1, 2, that's 2 10s. That's one group. Notice that I shaded 2 out of 2. Okay. So one more time. 1, 2. Right there. I shaded 2 out of 2. And this is 2 out of 10. There's one more group of 2 out of 10. One more group of 2 out of 10. One more group of 2 out of 10. So once again, notice that I shaded 2 out of 2. I shaded 2 out of 2. I shaded 2 out of 2. But I'm not done, right? I can do one more group of 2 out of 10. So once again, I shaded 2 out of 2. And then I have to see if I can do one more group. And notice that I'm only able to shade 1 out of the 2 right here. I didn't quite shade all of them. So I'm only able to shade 1 out of the 2. So how many groups was I able to shade in? 1, 2, 3, 4, 5, 6, and then 1 out of 2. So it's 6 and 1 out of 2. And there's my answer. Okay, so it matches this one there. There we are. Okay, so let's go ahead and do the last one there. The last one is 11 ninths divided by 3 ninths. So then once again, I'm going to do this based on my first one. So do 1, 2, 3, 4, 5, 6, 7, 8, 9. But I need 11. Okay, I need 11. So I need to do another one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I need to shade in 11. So 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. Now I need to make groups. I need to make groups of 3 ninths. So here's my first group of 3 ninths. Here's my second group of 3 ninths. So 1, 2, 3, 1, 2, 3. Here's my third group of 3 ninths. What you guys to notice though is that I shaded 3 out of 3. I was able to shade 3 out of 3. I was able to shade 3 out of 3. Now there's more, so I'm not done. There's 1, 2, 3. But wait a second. I didn't quite shade all 3 of them. I was only able to shade 2 out of the 3. So how many groups was I able to shade, right? Because I was only able to shade 2 out of 3. So 1 group, 2 groups, 3 groups, and then 2 out of 3. So 3 groups and 2 out of 3. That's my answer. And there you have it. And all right, I believe that's the end. So here's the summary of this lesson. All right, guys, go ahead and do your problem set. If you have any questions, you can leave them on the comments. If you find value on this, well, then give it a thumbs up. All right, I'll see you guys in the next lesson. Adios.